Good evening. Today we are going to see the problems which are on higher degree differential equations with constant coefficients. And in this, we are going to solve problems related with complementary function only. So we have already seen this complementary function, and we have three cases for this that already we have gone through. If you will see last video, in case one, we have roots are real and distinct. Roots are real and distinct. Already you can go to last video, so you will come to know. Then we have case two, roots are equal. Roots are equal. So we have, this is second, and case three we have roots are imaginary. Roots are imaginary. And now we will go with the problems. So let us, we have first problem that is given. So problem one. So we have d square minus 5d minus 6 into y equal to 0. See, we are relate only with complementary functions. So we have all problems, find CF only. So in first part, we will go CF, and then we will go PI. So, and then we will solve the problems from CF and PI addition, that is solution. So now in this, we have first d square minus 5d minus 6y, and that is equal to 0. This is Q, and already we know Q, this is related with your particular integral. And therefore, in all problems, when we will talk about complementary function, we will take Q0, and due to this Q0, automatically your PI becomes 0 because we have this value 0. So now we will go with this. Complementary function is very simple part in this, and therefore we will go with first. So now I will write auxiliary equation. So given equation, we have characteristic equation. And now we will write equation as auxiliary equation. So we have this equation, that is m square minus 5d minus 6, and that is equal to 0. So we have m square minus 5d minus 6, and that is equal to 0. Now in this, we have to go for the different parts, and in this, we have to go with roots. Now the given this equation, that is d square minus 5d, I already mentioned, this is symbolic or characteristic equation. Characteristic equation. And when we will write in terms of m, we have this as auxiliary equation. So we have minus 6, we have to go for the root in such a fashion. Multiplication, we will have minus 6, and addition, we have minus 5. And then in this, we have minus 6 and plus 1. And from this, we will get minus 6 into 1, minus 6. Minus 6 plus 1, we have 5. And then we can have m square. Then we can write it plus d minus 6d minus 6 equal to 0. You can write first minus 6. That also it's okay. That is your choice. Sorry, this is not d. We have actually minus 5m. And then this also we have m. This also we have m. And then, so I will write below m square plus m minus 6m minus 6 equal to 0. And then we will take from these two m common. And in bracket we will get it as m plus 1. Then we have minus 6 common in these two. And then again we will get m plus 1. And then equal to 0. And from this we will get m plus 1, m minus 6 equal to 0. And from this we will have m plus 1 equal to 0 and m minus 6 equal to 0. And from this we have m is equal to minus 1 and m is equal to 6. So we have case 1, roots are real and distinct. Roots are real and distinct. And then now we have to write complementary function. And then how we will have this complementary function? So we have complementary function equal to. So complementary function that is equal to. So we have C1 now e raised to m1x plus C2 e raised to m2x. Now m1 we have minus 1, m2 we have 6, and therefore we have complementary function equal to C1 e raised to minus x plus C2 e raised to 6x. And likewise, we can find complementary function for the given problem. So we have this as one problem where we have complementary function. C1 e raised to minus x and then C plus C2 e raised to 6x. So now we will go with second. We have problem 2. So we have given equation that is 2d square. So second problem, 2d square minus d minus 10 into y, and that is equal to 0. This is again characteristic equation or symbolic equation. We have to convert this into auxiliary equation. So we have solution, auxiliary equation. So we have 2m square minus m minus 10 that is equal to 0. So we have now AC 2 into minus 10 minus 20. So we require roots of this minus 20 whose multiplication is minus 20 and addition is minus 1. So we have this as 4 and minus 5. And then from this we can have this. So 2m square plus 4m minus 5m minus 10 equal to 0. Now we can take 2m common from this. We will get m plus 2. Now minus 5 we can take outside. We have m plus 2 and that is equal to 0. And from this we will get 2m minus 5 m plus 2 and that is equal to 0. Then we have 2m minus 5 equal to 0 and m plus 2 equal to 0. And from this we will get 2m equal to 5, m equal to 5 by 2 And another value we have m is equal to -2. So I can write this as m1 and then this will be m2. Now again we have case 1, roots are real and equal. Sorry, real and distinct. And then we have complementary function for this. We can write it as CF is equal to, we have C1 e raised to m1x plus C2 e raised to m2x. And now we can write CF that is equal to C1 e raised to minus 2x plus C2 e raised to 5 by 2x. So this is, we have complementary function of the given characteristic equation. Then we can have third problem. So we have third problem. So we have d square minus 4d plus 4 into y that is equal to 0. So we have given this as characteristic equation or symbolic equation. And now we will write auxiliary equation. So we have auxiliary equation m square minus 4d plus 4 equal to 0. Now we have 4 and addition also we have -4. So -2. So we can have m square minus 2d minus 2d plus 4 equal to 0. And from this we will get, sorry, not d. So this should be m. Again, this is m. So we have m square minus 2m minus 2m plus 4 equal to 0. Take m common, m minus 2. Take minus 2 common, m minus 2 equal to 0. And then we have m minus 2 equal to 0. And therefore we have m is equal to 2, m is equal to 2. So we have roots are real and equal. And then when we have this, so I have value of m2 comma 2. So what will be my complementary function? So we have complementary function equal to C1 plus C2x into e to the power mx. And from this we can write CF equal to C1 plus C2x into e raised to 2x. So we are being with this, that is problem number 3. So now we can go with next problem. So problem number 4. So problem number 4 we have d4 minus 2d cube plus d square into y equal to 0. So you can see this, we are taking all values of q as 0 because we are going to find only complementary function. So first part we are saying complementary and then we can go with particular integral. So auxiliary equation m4 minus 2m cube plus m square equal to 0. Now from this we can take m square outside. So we can have m square minus 2 plus 1 equal to 0. Now we can have this m square and this m square minus 2m. So this directly we can write m minus 1 whole square equal to 0. So we have d to the power 4. So we have 4 roots. Now m square equal to 0. So we have m equal to 0, m equal to 0. Two values. And then we have m minus 1 equal to 0 and m minus 1 equal to 0 because we have square, and therefore from this we will get m is equal to 1, then we have 1. So these two we are going to say as m1 and these two we are going to say as m2. And then what will be our equation? So now we have these roots are, these two are equal, first and second, and third and fourth are equal. So our complementary function becomes C1 plus C2x e to the power m1x plus C3. Now this I will say instead of m2, m3. So C3 plus C4x e to the power m3. Because m1 equal to m2 equal to m. So that we are considering as m1. And then m3 equal to m4 we have equal to 1. And therefore we will get it as complementary function equal to C1 plus C2x e raised to 0x plus C3 plus C4x e to the power x. E to the power 0x, you can write it as 1 also, because power to anything if 0, then we have value as 1. So likewise, we have this fourth problem. This is our second type. Now we will see the problems which are related with third type, where we have imaginary one. So now we will take one problem, that is 4d square. So we have fifth problem. So fifth, so we have 4d square, then minus 8d plus 7y equal to 0. And then this is again symbolic or characteristic equation. Now we will go with auxiliary equation. So we have 4m square minus 8m plus 7 equal to 0. Now we have to see it. Have we any roots of 28 which will use minus 8? So we do not have anything. So we have to use that formula. M is equal to minus b plus minus root of b square minus 4ac upon 2a. Now in this, we have a equal to 4, b equal to minus 8, c equal to 7. And then we have m is equal to 8 plus minus b square we have 64 minus 4, a is 4, c is 7, divided by 2 into 8. And from this we will get 8 plus minus root of 64 minus, we have 4 4 the 16 into 7, 112 divided by 16. From this we will get 8 plus minus root of, so 4 8 174, so minus 48 upon 16. Now we can take 16 outside from this, so it will comes 4, so 8 plus minus 4 root 3 I divided by 16. So now minus 48, root minus 48, we have root of minus 1 we have I into 16 into 3. And this 4 we have taken outside. Root of minus 1 is I. So we have 4I root 3. And that we have considered here. So if we will take 4 common from this, then we have 2 plus minus root 3I divided by 16. So we have 4 4s are 16. And then from this we will get values that is equal to m is equal to, sorry, we have this a that is 4. So this a, this becomes 8. This becomes actually 8. This is 8. And this 4 2s are 8. So this is 8 actually. 4 2s are 8. Because value of a is 4 and we have 2a. So I have taken directly 2a 8 value. So actually it is 2 into 4 8. And then we have this value. So if I will write below, m is equal to 2 plus minus root 3I upon 2. Separate it. So we have 2 by 2 plus minus root 3 by 2 I. So this is 2 to cancel. We have 1 plus minus root 3 by 2 I. So this is a real part known as alpha. This is imaginary part which is known as beta. So we have this as alpha, this as beta. And now if we will write complementary function for this, then we have complementary function C1 e raised to alpha x, sorry, e raised to alpha x into C1 cos of alpha x plus C2, sorry, C2, C1 cos of beta x plus C2 sine of beta x. A real part we have to consider power of E and imaginary part we have to take with cos and sine. And now if we will put the values, we will get complementary function equal to e raised to x in bracket C1 cos root 3 by 2 x plus C2 sine root 3 by 2 x. And from this, we can have complementary function for the given problem. So likewise, we have to solve the problems which will give us complementary function. Now we will stop here only. Remaining part we will see in the next video. So thank you.